Students, welcome to s.mathguru classes. Today we shall start the inverse Laplace transform. Laplace transform, it was given. Now we consider inverse Laplace transform. So what is inverse Laplace transform? First we consider the definition of inverse Laplace transform. If L of ft equal to f of s, then L inverse f of s equal to ft. This one. If L of ft equal to f of s, then L inverse fs equal to ft, where L inverse is called the inverse Laplace, or L inverse is called the inverse Laplace transform operator. So this is the definition of inverse Laplace transform. L of ft equal to f of s, then L inverse fs equal to ft, where L inverse is called the inverse Laplace transform operator. Now what is inverse? Now we consider some formula. We know this formula. Number 1, L of 1 equal to 1 by s. We know this. Number 2, L e to the power at equal to 1 by s minus a. Number 3, L cos hyperbolic at, then this equal to s by s square minus a square. L sin hyperbolic at, then a by s square minus a square. Number 5, L cos at, this is s by s square plus a square. This direct formula. L sin at, this is a by s square plus a square. These are the formula of Laplace transform. Now we want to write inverse Laplace transform. Number 1, L inverse 1 by s. This is 1. This formula. L inverse 1 by s is 1. Number 2, L inverse 1 by s minus a. 1 by s minus a means e to the power at. So this will be e to the power at. Number 3, L inverse s by s square minus a square. S by s square minus a square cos hyperbolic at. So this will be cos hyperbolic at. Number 4, L inverse a by s square minus a square. This is sin hyperbolic at. This formula. Again, number 5, L inverse s by s square plus a square. This is cos at. And number 6, L inverse a by s square plus a square. This is sin at. This formula we write in reverse. L inverse taking here, then cos at, L inverse, then sin at. Another formula we have, number 7, L inverse 1 by s to the power n equal to t to the power n minus 1 by factorial n minus 1. So there are different formula we have, but these are the main fundamental formula. If we by heart this main formula, just we write reverse, L inverse 1 by s, then 1. L inverse 1 by this, then we get e to the power at, just like this. Same formula we write in reversely. So these are inverse Laplace transform formula. Now let us consider some problems. There are some problems about inverse Laplace transform. These are very easy problem and solution also very easy. Find the inverse Laplace transform of the following: 1 by s minus 2, 1 by s square minus 9, 1 by s square plus 25, s by s square plus 9. 1 by s minus 2 whole square plus 1, s minus 1, s minus 1 whole square plus 4. Number 7, 1 by s plus 3 whole square minus 4. And number 8, s plus 2 by s plus 2 whole square minus 25. Now solution is start. First we consider number 1. L inverse 1 by s minus 2. S minus 2 we consider. We know this formula. L inverse 1 by s minus a. This is e to the power at. L inverse 1 by s minus a, e to the power at. So here a means 2. So this answer will be e to the power 2t. 1 by s minus 2, e to the power 2t, and this is our answer. Next, number 2. L inverse 1 by s square minus 9. So this can be written as 1 by 3 L inverse 3 by s square minus 3 square. This 9 means 3 square, and this 3 we write here, and here also 1 by 3. This 3 cancel, we get 1. But we know this formula, L inverse a by s square minus a square. This is sine hyperbolic at. A by s square minus a square, this is sine hyperbolic at. A by s square minus a square. So this will be 1 by 3 sine hyperbolic 3t, and this is our answer. So number 2 we get. Next, number 3 we consider. Number 3, L inverse 1 by s square plus 25. We consider number 3. So this equal to L inverse s square 25 means 5 square. So we write numerator is 5, here also 1 by 5. So this 5 cancel, we get s square plus 25 units. But we know this formula, L inverse a by s square plus a square, this is sine at. A by s square plus a square is sine at. So this is 5 by 5 square plus s square plus 5 square. This is 1 by 5 sine 5t. Here a means 5, and this is our answer. Very easy solution. And number 4 we consider L inverse s by s square plus 9. So L inverse s by s square plus 3 square. 9 means 3 square. So direct formula we know, L inverse s by s square plus a square. This is cos at. If s, then cos. S by s square plus a square, cos at. So this will be cos 3t. And this is our answer. So up to 4 done. Problem number 5. So this one 5 we consider L inverse 1 by s minus 2 whole square plus 1. Now for solving this problem, we consider first shifting theorem. We consider first shifting property. First shifting property. First shifting property, if L inverse f of s equal to ft, this implies L inverse f of s minus a or plus a equal to L inverse equal to e to the power minus at L inverse fs, or we can write L inverse f of s minus a e to the power at L inverse f of s. These are first shifting property. L inverse fs equal to ft, then if we have s plus a, if we remove this a, then e to the power minus at. If it is plus, then you get minus at L inverse fs. If it is minus, then e to the power at L inverse fs. We get this. So this is our first shifting property. Now we remove this 2 from this. We remove 2. If we remove a, then e to the power at and L inverse this. So we remove 2. Then we get e to the power 2t L inverse 1 by s square plus 1. We get this. If we remove this 2, then we get e to the power 2t L inverse s square plus 1. 1 means we can write 1 square. So again you know this formula, L inverse a by s square plus a square. This is sin 80. We know this formula. So here a means 1, 1 by s square plus 1 square. So this will be sin 1t or t simply. This is our answer. Next, number 6 you consider. Number 6, L inverse s minus 1 whole square plus 4. Now here we get s minus 1, here also s minus 1, this formula. If we get L inverse s minus a, then if we remove this a, then e to the power 80 L inverse fs. So we remove this 1, then this is e to the power 1t L inverse s by s square plus 4. 4 means 2 square. So this is direct formula, s by s square plus a square cos 80. And this is our answer. Answer we get this one. Next, number 7 we consider. In 7, this one 7. L inverse 1 by s plus 3 whole square plus 4. This. Now if by first shifting property, if it is plus a, then e to the power minus a. If we remove this a, e to the power minus a, L inverse fs. We remove this 3, then e to the power minus 3t L inverse 1 by s square minus 4. We get this. So again, we write this, just remove this 3, we get e to the power 3t, and this one remains same. E to the power minus 3t L inverse, if we write 2 by s square minus 2 square, s square remains same, 2 square means for this 2 write extra, then we write outside is 1 by 2. We get this. But this is formula we know, L inverse a by s square minus a square. This is sin 80. Sin hyperbolic 80, because denominator is minus. Sin hyperbolic 80. So this is s square a by s square minus a square. So this will be 1 by 2 sine hyperbolic 2t, or we can write 1 by 2 e to the power minus 3t sine hyperbolic 2t, and this is our answer. We get 7 number answer. Next we consider 8 number problem. Number 8, L inverse s plus 2 by s plus 2 whole square minus 25. This. Again, this formula I consider s plus a. If we remove a, then e to the power minus at, L inverse at is. We remove this 2. From this 2, remove 2. Then e to the power minus twice t, L inverse s by s square minus 25. 25 means 5 square. Again you get direct formula. The formula is L inverse s by s square minus a square. This is cos hyperbolic 80. So this is e to the power twice t, and this is s by s square minus a square cos hyperbolic 5t, and this is our answer. Very nice solution. These are very nice solution, very easy, very important also. These are and for engineering courses, these are most important. So I hope you are all enjoying with this problem, and if you are enjoying, then please share the video to other engineering parents also and other BHC maths major also. Thank you for watching the video.